Hi, in this video we are going to talk about level order traversal line by line. Let's take a look at these examples to understand the problem. We are given this tree, we need to print level order traversal, but before printing the new level we need to print a new line. So we print 10 first, then we print a new line, then we print 20, 30 after the new line, then we print 40, 50, 60 and then we print the last level 70, 80. If there is only one node at every level, then we will have a new line after every node. Let's see this example. 5, first level, then new line, then 310, then 15. Now please pause this video and try to write down a function that takes root as a parameter, does not return anything, prints level order traversal line by line. Let us now talk about solution of this problem. We are going to discuss two solutions. Here is first solution, and the idea is based on this fact that when you traverse the last node of a level, your next level is completely there into the queue. So what we do here is, when we traverse the current level completely, we push a null marker into the queue. And when you see null next time, you are sure your complete next level is there in the queue, so you can push another null. Let's understand this with an example. We first push 10 and a null into the queue because 10 is the only node, and we put end of level marker as null. Now when we take out 10, we put 20 and 30 into the queue, right? And after taking out 10, we see null to take out. So when you take out a null from the queue, it means you have reached end of the current level. So you print a new line and you push null into the queue. So why are we pushing null into the queue now? The idea is again based on this fact. When you see a null, it means you have reached the end of current level, which means your next level is now completely there into the queue. So you can put a null into the queue as end of level marker for next level. So when you see null, you print a new line and you push another null into the queue, which it means your end of level marker for next level is also pushed. And we are sure when we are seeing a null, it means we have reached the end of current level and we just need to push end of level marker for the next level. So when we take out 20, we simply print it. Then we take out 30, we simply print it. Then we see a null, so we push another null. Now we take out 40 and print it. Now we see a null. When your queue size becomes 1, it means you have null only left into the queue. It means you need to stop the level order traversal line by line. So here are the codes for the implementation. We are creating a queue in both Java and C++ implementations. Then we are adding root into the queue. Then we are pushing null into the queue. Then we are running a loop which is while queue.size is greater than 1. Please note that this condition is different from normal level order traversal. In normal level order traversal, we have the condition while queue is not empty. Here, our termination condition is while queue size greater than 1, because at the end, we will have one node into the queue. And inside this loop, what we do is, we again do something similar to level order traversal. We take out a node, and after taking out the node, we need to check here whether this node is null or not. If this node is null, then we push a null and we push a new line. If this is not null, we follow similar to level order traversal. We print it and we check if its left and right children are null or not. If they are not null, then we enqueue left and right children. If this is null, then we print a new line and we push another null into the queue, and then we continue. Continue means we do not execute these 3 lines for null pointer, right? Similarly here, when your current is null, you do not want to execute these 3 lines. You want to execute these 3 lines only when current is not null. We could have put it in the else part also. We have used continue here to skip these 3 lines for null case. Let us now talk about time complexity of the solution. We are going to print every node exactly once, and every node is going into the queue exactly once and coming out of the queue exactly once. Now, how much extra time we need to process nulls? See, there will be big O of h extra nulls because you have a null for every level only. So the time complexity can be written as big O of n plus h. where h is height. Now height can be ignored because it's a lower order term than n, so we can say time complexity is big O of n. How much auxiliary space it requires? We can always say auxiliary space for a level or a traversal is theta of width, even in this case, because we'll have width plus one extra null. So 1 is not counted in asymptotic notations. It's a constant, we can ignore it. So we say that time complexity of this solution is big O of n and auxiliary space is theta of width. And auxiliary space can also be written as big O of n because width can go up to theta n. Remember this perfect tree example, right? Width is almost n by 2. If you have 31 nodes in a perfect tree, you will have 16 nodes as leaves, which is your maximum width, which is 31 plus 1 by 2. So the time complexity is big O of n and auxiliary space is big O of n or theta of width.